want us to take a few notes from yesterday. Sasha, I can see that you raised your hand. Let me recap from yesterday, and then I will attend to you just now. So yesterday we spoke of the periodic table. You all now know what is a periodic table, what is an element, what are elements, how many elements, and how elements are classified. I'm having a bit of a trouble with my screen here, but I'm just gonna catch up with you now. So yesterday we spoke of elements. We said elements are found in a periodic table. We said we've got 114 elements in the periodic table. So before I switch off my video, I want to thank everybody who has communicated with me via my social media pages. Here are my social media pages, guys. You can ask questions and I promptly respond. On Twitter at MbataX, on Instagram at XKIM. Thank you so much for communicating with me. I answer all the questions immediately. So today, let us have a bit of a recap. Remember, if you feel that I'm a bit too fast, please raise your hand. I'll slow down, or you can catch the video live on Instagram, on YouTube. You can even go and watch the video later on. So yesterday we looked at, I'm having trouble today, grade 9s. What's happening? I'm having problems moving my slides. I don't know why. Okay. At the end of this lesson, you will know this, guys. You'll know formulae for compounds, classification of elements, of which I've already touched on yesterday. And then you're gonna know how we name the naming of compounds. We did that yesterday. Then we said elements in the periodic table can be classified into 3. We've got 3 groups. You've got metals, non-metals, semi-metals, and those are the 3. And then we said most of the elements in the periodic table are metals. And then we know that if metals react with oxygen, I will tell you what we get. If non-metals react with oxygen, what do we get? And then we said only mercury is room at temperature. If you remember yesterday, grade 9s, we did this. We said most of the elements in the periodic table are metals in the middle, and you find them in the middle of your periodic table. I'm expecting you that you are already now familiar with your periodic table after yesterday's lessons. And then we also discussed this. And then there are few elements on either side of the black zigzag. So when you're looking at your periodic table, grade 9s, you will see that you can actually separate it into 3. You've got your left, your middle, and your right. And then we said in the middle, mostly are metals. There is there we go. Looking at this, what you call, looking at here, when you're looking at in the middle, going to your left-hand side, those will be your metals. Here in the periodic table, they are pink. And then here in your zigzag, they are your semi-metals, and then you've got your non-metals. The zigzag here, your, what you call, this will be your semi-metals. That means they've got both characteristics of metals and non-metals. So metals, pink, semi-metals, they're here, and then non-metals, they are here. Hope you are following grade 9s. Then we said compounds. Yesterday we did this. We said compounds are made of elements that are joined together. So element plus an element, we get a compound. And then we use the symbols of elements to write the formulae for compounds. For example, water is a compound, right? We all know that water is a compound because the elements that are making up water, it is hydrogen and oxygen. So when you join hydrogen and oxygen, you get water. Symbol for hydrogen and oxygen are used to write the formulae for water. The formula also tells the ratio of the number of each element in the compound. The formula for water tells that there is a ratio of 2 hydrogen atoms to 1 oxygen. So if you're looking here at this is a compound for water. So you've got 2 hydrogens and 1 oxygen. 2 hydrogen atoms and 1 oxygen atom give us water. H2O, H2O. And then let's skip that quote. That's my quote, guys, there. It says, if celebrities had greater minds, they all would be scientists. So that's why I love science so much. Then can you please, grade 9, memorize the first 20 elements of the periodic table? Grade 9s, I did say that we know what is a group and what is a period. I said we've got 7 periods and we've got 18 groups in your periodic table. Please remember that. So let us look at the first 20 elements that you will find in your periodic table. So it's the hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Why am I reading this out to you? I want you to look at their symbols, grade 9. It is important for you to know the element symbol when you are writing a compound. Let us look at sodium, guys. You see sodium, the symbol is not S, but it is Na. So Na represents sodium. What else I want you to look at? It's potassium. P is not a symbol for potassium, but K is. Are we clear on that one? So if they say to you in a word equation, potassium plus sodium, so you need to know you're not going to write P plus S, but you will say K plus Na, and then you will get what? You will get the product that you will get there. But please know the symbols of each element. Know how we represent it, because it's easy for fluorine, because the symbol for fluorine is F. The symbol for oxygen is O. But when it comes to sodium and potassium, it's not the same. Remember, elements are classified into 3: metals, non-metals, and semi-metals. I have already explained that. So then we said 2 elements form a compound. So a compound is a pure substance that is formed by a chemical reaction between 2 or more different elements. Remember that a compound can be more than 1 element. Can be more than 2 elements, I'm sorry, because an element plus an element gives us a compound, but element plus element plus element will still get a compound. Remember that we use symbols of the elements for the reaction. So chemical equations, they represent reaction. So if they're saying a reaction, write a reaction, you are going to write chemical equation. You already know that chemical substances can break apart and join together in a chemical reaction. The substances that react together are called the reactants. And then we can use models to help us understand. So now for a class, Jaden, I see your hand, I will attend to you. Or you can write your question, Jaden, there by the chat box so that I can attend to it. But as I mentioned earlier on, I prefer that we use my social media so that you get my undivided attention there by the inbox. So you see, we said formula, it's H2O, the name is water. What is H2? H2 is hydrogen. What is O2? O2 is oxygen. I will explain why we're representing it as H2 or O2. We will talk about diatomic molecules after this as we continue. As we continue grade 9, I will explain what are diatomic molecules. Why is hydrogen written as H2 and oxygen is written as O2? I will explain as we progress. But just keep in mind, caps lock, diatomic molecules, then or diatomic elements. You will know what are diatomic elements as we continue. And then we've got CO. This is carbon oxide, carbon oxide. It's a reaction between carbon and oxygen, and then we get carbon oxide. Then we've got CO2, and then CO2 is carbon monoxide, carbon monoxide. It's carbon dioxide here. This is it's carbon dioxide because we've got 2 oxygens and 1 carbon. The CO2, it's a carbon dioxide, and then CO, and then with CO it's carbon monoxide, where carbon has obviously reacted with 1 oxygen, and then we're gonna have carbon monoxide. Then we've got CO2, we've got carbon dioxide, and then this is copper oxide. This is copper oxide. Then when sodium reacts with chlorine, we get sodium chloride. That's your kitchen salt. You know, when you're eating and then you want salt, you want this. When sodium reacts with chlorine, we get sodium chloride. And then SO3, what is SO3 grade 9s? What is SO3? I'm looking at my chat box. I want to see if you are following me. And I have given you, I have Daniela, I have you, and please write your question there on the chat box. Let us continue grade 9s. So you're using symbols and formulae to represent reaction. This is called a chemical reaction. And I've been telling you grade 9s, when an element reacts with another element, we call that a reaction. So now this is, it's a chemical reaction because those are chemicals reacting. So when hydrogen reacts with oxygen, it forms water. So now we've got diatomic elements here, H2 plus O2, we get H2O. So now this is a balanced equation for water. Remember, diatomic elements, oxygen gas and hydrogen gas are often used in chemical reactions. If the atoms in these gases react in pairs of 2s, certain elements are not built using a single atom. They consist of diatomic elements, guys. So I will tell you as we proceed about the diatomic elements. It's not only hydrogen and oxygen. We've got these ones. The elements, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are made up of diatomic molecules. James, please write on the chat box. Whenever we use them as elements in reaction, that is when they are not part of a compound, we must write them H2, N2, O2, F2, Cl2, bromine 2, iodine 2. Are we clear? Those are diatomic elements, grade 9. Diatomic elements, please write down diatomic elements. Those are diatomic elements. That's how we represent them. Then name the reactants and the products in the following chemical equation. C plus O2, we get CO2. Is the above chemical reaction balanced, grade 9? Is it balanced? Yes, it is balanced. Why is it balanced? Because we've got 1 carbon this side, we also have 1 carbon this side. Do you follow, grade 9s? It's 1 carbon here, and then we have, yes, and then when the reactants, we're looking at the reactants here. We've got reactants, carbon reacting with an oxygen here, and then we're getting carbon dioxide, and then we still have 2 oxygens on the left, and then we have 2 oxygens on the right. one carbon on the right and one carbon on the left. Therefore, the equation is balanced. But when you go back to H2O, let us go back to H2O. If you, before you put replaced with these two red twos, you see this number 2 red and this number 2 red, it was when I was balancing. We had H2 plus O2 here, we got H2O. So on the left, we had 2 hydrogen and we had 1 oxygen. This side we had 2, on the left hand side we had 2 oxygens and 2 hydrogens. When we come to the left hand side, the product now, the compound, we had 2 hydrogen and 1. Therefore, now we're gonna have 4 hydrogen atoms on the right and 4 hydrogen atoms on the left. We have 2 oxygen atoms here, and then we have 2 oxygens this side again. I hope you understand how we balance the equation. Remember diatomic elements as well. And then they say hydrogen reacts with oxygen to form water. I'm also now showing you here the not balanced one and the balanced one. Raise up your hand if you understand grade 9s. Yay, everyone is understanding. I hope you understand how we balance. Yes, thank you so much, grade 9. Everybody is following me. I appreciate grade 9s. Then let us look at zinc again, grade 9s. When you're looking at zinc, when zinc reacts with oxygen to form zinc oxide, we get this equation. Okay, let us focus now, grade 9. Let us stop raising hands. Let us focus now. Thank you so much. Let us look at the zinc one again. We are balancing the equation now. If zinc reacts with oxygen to form zinc oxide, so we get zinc plus O2. So zinc is 1, but we've got 2 oxygen atoms this side, and then on the right we have 1 zinc, and then we have what you call oxygen. So it is not balanced. How are we going to balance it? How are we balancing it? And then now we're saying, okay, zinc oxide, zinc and zinc, they're still 1-1, but oxygen is not happening. Let me fix this. Let me fix this, grade 9. This is how we represent. We're not representing oxygen like this. We represent oxygen like this. Then we are happy. I'm happy. We are all happy. So we've got oxygen here and then 2 molecules. Then now, because I've replaced with 2 here, we're gonna have 2 zinc and 2 oxygen, 2 oxygen and 2 zinc, and then the equation is balanced. Are we clear, grade 9s? You are following me. I can see that. Thank you very much. Atoms are conserved in a reaction. Are we clear, grade 9s? Atoms are conserved in a reaction. During a chemical reaction, atoms are not lost. We always gain atoms. The original atoms in the reactants are simply rearranged to form new groups of atoms in the products. Are we clear? We don't lose any atoms during the reaction. We always gain atoms. Balancing equation, when we write a chemical equation, we have to balance it. Make sure it is always balanced. The total number and the type of atoms in the reactant is the same as in the products. So now, if you've got elements this side reacting, please make sure that the compound that is formed, the elements are still the same. They are still the same, you know. They must be balanced. That's why we have to balance the equation. This means that there must be the same number of atoms of each type on either side of the arrow in your chemical equation. Grade 9s, you do not want a chemical that is not the product that is not balanced with the reactants. You cannot have 1 + 1 and then you're getting 20. We need to balance our reactants, which are reactants, and our product, which is a compound that is formed by the reactants. Are we clear on that one, grade 9? Thank you. Write down the symbol and the formulae for all the substances. Remember that certain elements are diatomic. I've been saying that we've got diatomic elements, né? And then I gave you all of them, that your hydrogen, your oxygen, your nitrogen, your fluorine, and so on. At the beginning, I gave you the list of the diatomic elements. Make a picture drawing. These are the steps of balancing a chemical equation. Please know all 7. So you've got, you write it down, H2 plus O2, you're getting H2O, and then make a picture drawing of the equation to help you count the atoms, as you always did in grade 8. Remember those circles, and then you'll choose that your hydrogen will be unshaded, and then your oxygen, your hydrogen, you will shade it, and then this side you will have 2 balls for hydrogen, which are shaded, and 1, and then you continue balancing by adding those balls. You remember, that's the picture drawing I'm talking about. And then you need to count, number 3, count the atoms of one element on the either side of the arrow. So you need to count the elements. How many elements do I have on the left? How many elements of hydrogen do I have on the left? How many hydrogen elements do I have on the right? Okay, here is 2, here is 2. Okay, I'm okay. And then how many of oxygen do I have? Here is 2, here is 1. Therefore, your equation is not balancing. Ne? What do? You go to number 4 now. Try to make the atoms on either side of the arrow equally by adding more molecules to the side where you do not have enough. So now you're gonna come here now. Say, okay, because I don't have two atoms of oxygen this side, what do I do? Remember, you cannot put the 2 here. You're gonna put the 2 here, because H2O is 1, it's a compound. So you're gonna put the 2 here. Okay, now what's going to happen? You're gonna have 2 by 2, it's gonna be 4 hydrogen atoms. 2 by 1, it's gonna 2 by 1 oxygen atom, it's gonna be 2. Okay, now I've got 2 oxygen atoms this side and 2 oxygen atoms this side. And then this side, oh, I've got 4 now here. 2 by 2, it's 4 hydrogen. 2 by 1, it's 2. And then you say, okay, since I've got 4 hydrogen atoms this side, what do? You go back to your left-hand side and you need to put in that 2 now. Remember, this 2 will only apply in hydrogen, since we've got an operation here of an addition sign. It's an operation here, so it will be this. But here, it's a compound, so they work for both. That's why I said 2 by 2, it's going to be 4 hydrogen atoms. 2 by 1 oxygen atom, it's going to be, it's going to be 2 oxygen atoms. Therefore, we've got 2 oxygen atoms this side, and then we've got 2 oxygen atoms this side. We've got 4 hydrogen atoms this side. We're gonna have 4 hydrogen atoms this side. We are balancing. So I put on this 2, and I put on that 2, and then I was balancing. Are we following grade 9s? I hope we are following, and you need to know these steps. You need to know these steps. You need to know these steps. You need to know these steps, all 7 of them, for you grade 9s to actually understand what is happening here. Remember this, grade 9, important hints from me to you. Important hints. When balancing equations, remember the following. There must be an equal number of each type of atom on either side of the arrow. You cannot change the composition of a molecule, only the quantity of a molecule. You cannot change the composition, only the quantity. Do not use small numbers in the formula to add atoms. Only use big numbers in front of the formula, guys. You cannot say you're going to put 1 because we do not write 1. Just like in mathematics, remember, if if it's 1x, we only write x. Remember that in mathematics, right? You cannot write 1x. So same here, you cannot write 1h plus 1o. No, only when you're starting to balance now, you're gonna write 2, 3, you're going up with the bigger numbers. Né? I would prefer if we use even numbers, it will be much better to balance the equation. These are helpful links, grade 9, very, very helpful, so that you continue with the lesson even if I'm no longer here in front of your screen. You can always follow those links. So homework, your homework, grade 9, here is your homework. Please write it down. If you've got any problems while writing the homework, please, by all means, I see you are raising hands, but I'm begging you, please, if you're having any problems answering this homework, please go to Twitter or Instagram. On Instagram at XKIM, on Twitter at MbataX. Direct message me. Don't write on my wall, please, because you won't be able to get answered. Just direct message me. Those of you who have DM'd me, they know that I answer immediately. I don't waste time. So I'm here for you, grade 9s. I'm hoping that you are following what I'm teaching you here. So next lesson, we're going to look at reactions of metals and non-metals with oxygen. We're going to know what is combustion. This is on Monday. Monday, we are doing reactions from A to 0. I will be typing in, showing you how we're balancing as I was showing you today. Today, I was just showing you the glimpse of the interesting part of chemistry, guys. Chemistry is very, very interesting. So on Monday, make sure that you are joining me again. I will be typing in. We will have less notes and more of practice. What do we get when metals react with reaction of metals and non-metals with oxygen? What do we get? Because remember that most things they react very well with oxygen. What is combustion, grade 9s? This is your homework. You need to know this before we come to the lesson, because we will be gun blazing Monday with this. And please do not miss Monday's lesson. If you are planning to be a nurse, a doctor, and a chemical engineer, on Monday, we'll be on flick. We'll be doing chemical reactions. We'll be working very hard. You will know what is an oxide, what a metal oxide. You will also know what is rusting, guys. Why do we have to paint our metal stuff when we have used them? Why do we keep on painting them? Remember the color of your roof at your school. Why do we paint it? Are we clear on that one, grade 9? Remember to follow us. For more information, you can contact at African Teen Geeks, or you can follow us on social media at African Teen Geeks, or at Iziora, at Sasol Foundation, at DBESA, or you can actually hashtag us at STEM Champions. I thank you, grade 9s. I see you on Monday. Thank you very much. I see the questions already on Instagram. I'm going to be attending to that. Thank you very much.